Welcome to AP Calculus class. Today our lesson is called Product and Quotient Rules and Higher Order Derivatives. So you're just going to take some notes on your own sheet of paper. Product, which of course means what you get when you multiply, and quotient rules and higher order derivatives. Okay, so the first problem that we're going to do is f of x equals x squared plus 2 in parentheses times x minus 6. Now, we have found derivatives of functions like this before. We did that by first multiplying using FOIL, first, outer, inner, last. So we get x squared times x, which is x cubed. Outer is negative 6x squared. Inner product, positive 2x. And then the last product, negative 6 times 2, gives us negative 12. There are no like terms to combine. Every term has a different degree. So now you're ready to take your derivative by using your power rule. So f prime of x would equal 3x squared minus 12x to the first plus 2. And then, of course, the derivative of negative 12 is 0. So nothing bad with the way we solve that problem, but today we're going to learn a new way to solve this problem that is called the product rule. This is a product of two functions. So in order to do this rule, I'm going to identify this first function as my u function and the second function as my v function. So we have a rule that will go on a note card for you to study, d dx, which means the derivative of, with respect to x, u times v. So this represents u times v, one function times the other function. U is a function, v is a function. Is going to equal u v prime plus v u prime. So what this means is you just copy down the first function as it is, multiply it by the derivative of the second function, and then add that to the second function, copied down just as it is, times the derivative of the first function. Okay, so how does that work with this? F prime of x is going to equal, we're going to take that first function u and just copy it down, x squared plus 2. Then we're going to multiply it by the derivative of the second function. So what's the derivative of x minus 6? Just 1, right? Plus the second function copied down, x minus 6, times the derivative of the first function. U prime is the derivative of the first function. So the derivative of x squared plus 2 would be 2x. So then all that's left to do is simplify and combine any like terms that we may have. So 1 times this is just x squared plus 2. Then we're going to distribute this 2x. So we'll have 2x squared minus 12x. And then we do have two terms that are second degree with x squareds in them. So we will combine those to get 3x squared minus 12x plus 2. And that is the same answer we got by doing it the way we learned previously, FOILing it out and then taking the derivative. So both ways work. Is one way better than the other? Well, this one took 2 steps. This one looks like it took 3, so that one might have been a shorter way. But sometimes it is to our advantage to do it using the product rule, especially when we get into more complex products. So we will take a look at some of those. And I wanted to point out that this would not be the same thing if we said, okay, my original function is x squared plus 2 times x minus 6. What if I just took the derivative of this first function, let's see, that would be 2x, and multiplied it by the derivative of the second function, 1. Would that work? No, 2x is definitely not the same as either of these answers. So you can't just take the derivative of each term and then multiply those derivatives together. That is not a valid way to find derivatives. So you either have to multiply first, then take the derivative, or use the product rule, and there's definitely going to be some problems where you must use the product rule. Okay, so number 2, second example today, we're going to have x squared minus 3x plus 2 multiplied by x cubed plus 1, and we're going to take the derivative of this. So one way to do it would be to multiply all this out. Since we have a trinomial here, we would have to like distribute to each term, which would take a while. So I'm not going to even bother doing it that way. I'm just going to apply the product rule right off the get-go. So this is our product rule. Put a little highlighter around it. Product rule. So we are going to copy the first function, x squared minus 3x plus 2, and multiply it by the derivative of the second function, so that's going to be 3x squared. Plus, copy the second function, x cubed plus 1, and multiply that times the derivative of the first function, which would be 2x minus 3. So now we simplify. The derivative work is done here. Like if this was a free response question on the AP exam, you've taken the derivative at this point. The only thing left to do is to simplify it and clean it up. But I will tell you that these normally would be found on multiple choice, and the answers are always simplified. So it is important to practice working on simplifying your answers. So now I'm going to distribute the 3x squared to each term. So it's going to be 3x to the 4th minus 9x cubed plus 6x squared. And then we're going to FOIL these two binomials out. So it'll be 2x to the 4th minus 3x cubed plus 2x minus 3. And now we're going to combine our like terms. So 3x to the 4th goes with 2x to the 4th to make 5x to the 4th. Negative 9x cubed goes with negative 3x cubed to make negative 12x cubed. And then we have just one quadratic term plus 6x squared, one linear term plus 2x, and one constant term, negative 3. So that's the derivative of the original function. Let's see, y equals y prime equals. So it only took one step to take the derivative, 2 steps to simplify it. All right, number 3. We've taken a look at the rule called the product rule. We're now going to learn about the quotient rule. F of x is equal to x squared over 2x cubed. We've done problems like this. We just said, well, why don't you simplify it before you take the derivative? So like x squared divided by x cubed would just, the x squared would cancel on the top and the bottom because x squared divided by x squared would be 1, and you'd be left with one single solitary x to the first on the denominator, which you could write as 1/2 multiplied by x to the negative 1, which would be an easier way to apply the the power rule. Getting my rules names mixed up here. So now I've got f prime of x is equal to negative 1 times 1/2 is negative 1/2, x to the power of, subtract 1 there, so negative 2, which is the same thing as negative 1 over 2x squared. So that's the answer. Now, we're going to learn the quotient rule, but on this particular problem, I probably wouldn't use the quotient rule. This would definitely be a more efficient use of time to do this problem, but we will get the same result using the quotient rule, and then we'll use the quotient rule on some problems where you couldn't simplify like we did here before you took your derivative. So this is the quotient rule. D dx, the derivative of u over v. So one function's on the top called the u function, one function is on the bottom called the v function. That's your numerator, that's your denominator. Is equal to, start with the bottom, v, multiply by the derivative of the top, u prime, minus the top, u, times the derivative of the bottom, v prime, all divided by the denominator v squared. Not the derivative of the denominator, just the plain old denominator squared. Now, I have found that students in the past felt that this rule was difficult to memorize. Because of the subtraction here, the order matters. So I'm going to show you a couple of other ways that you can remember this formula if you so choose. If you like it the way it is, just go with it. But some students have told me that they found these helpful. In fact, both of them were suggested by former students of mine. So I'm just going to share them with you in case you find them helpful. Let's say instead of calling it the derivative of u over v, we call it the derivative of high over low. So the top is the high function and the bottom is the low function, numerator, denominator. So we're going to start with the bottom, low, times the derivative of the top, high. So I'm going to call it d high, which means derivative of the top function, minus the top function, high, times the derivative of the bottom function, d low, over low, low. Low times low, that's the denominator squared. So low d high minus high d low over low, low. If that helps you to memorize it, because it kind of has a little ring to it, go for it. If not, just stick with the general formula. There is one slight alteration to this silly thing that some students liked better, and that's high over ho. Like hi ho, it's home from work we go. You know, the Snow White and the Seven Dwarfs song. Okay, so this one goes ho-de high minus hi-de ho over ho ho, like Santa Claus says ho ho. Okay, so that's 3 different ways to memorize this formula. You have to know it, you have to know how to use it, but whatever way works best for you, go with that way. So we're going to look at this, and I'll write, this is the quotient rule. Definitely goes on a note card to be studied. Okay, so we are going to do this problem using this rule. So f prime of x is going to equal the bottom function, the denominator, the low, or the ho, whatever you want to call it. It's 2x cubed. Just copy. All right, so now we're going to multiply the bottom function times the derivative of the top. So the top was x squared, so the derivative of that is 2x. Minus the top function copied down, so x squared times the derivative of the bottom function. The derivative of 2x cubed is 6x squared, all divided by the denominator, which was 2x cubed, quantity squared. Make sure you put it in parentheses before you square it. The whole thing gets squared, not just the x. So now we're going to simplify this. Technically, we have taken the derivative on this step. Technically, if it was free response, it could just be left like that. But they are very seldom going to put this just as a free response question. It's more often going to be multiple choice, and the answer choices will all be simplified. So we're going to practice simplifying. So 2x cubed times 2x gives us 4x to the 4th, minus x squared times 6x squared gives us 6x to the 4th, all divided by 2 squared is 4, x cubed squared is x to the 6th. And now we'll combine those terms in the numerator. 4x to the 4th minus 6x to the 4th is negative 2x to the 4th, divided by 4x to the 6th. And now we're going to simplify the numerator and the denominator. So negative 2/4 simplifies to negative 1/2, and x to the 4th over x to the 6th is going to be 1 over x squared, so the x squared would be on the denominator with the 2. And as you can see, this is the same answer we got using the other method. On this particular problem, as I said, I would definitely use the first method because it's easier. But on the next problem that I'm going to give you, you wouldn't be able to do that, so we would use the quotient rule for sure. So let's look at that one. Number 4. Y equals 4x plus 1 over x squared minus 5. And we're going to find dy over dx. So we're going to use the quotient rule to get the derivative. Start with the bottom, the denominator, x squared minus 5. Multiply it by the derivative of the top. The derivative of 4x plus 1 is just 4. Minus the top function copied down, 4x plus 1, multiplied by the derivative of the denominator. The derivative of x squared minus 5 is 2x. All over the original denominator quantity squared. So now I'm going to simplify. Distribute the 4x squared minus 20. And now I'm going to, let's just multiply 2x into both of these by distributing, and we'll worry about the sign after that, so we'll keep it in parentheses. 2x times 4x is 8x squared plus 2x times 1 is 2x, all divided by x squared minus 5 quantity squared. And now we're going to distribute the negative, so 4x squared minus 20 minus 8x squared minus 2x, all over x squared minus 5 quantity squared. And now we have like terms. There's a 4x squared can be combined with the negative 8x squared to give us negative 4x squared minus 2x minus 20, all divided by x squared minus 5 quantity squared. And that is the answer for the derivative. The denominator could be FOILed out if you wanted to, but it is absolutely unnecessary to do so because a factored denominator and a multiplied out denominator are both considered equally simplified. And on the numerator, you could factor it if you wanted to, but it's not necessary to do so. Again, it doesn't matter whether it's expanded or factored form, just as long as it's fully factored or fully expanded. Either one is acceptable and would probably be pretty easy to compare with the answer choices to check to see which one is equivalent. Okay, let's go on and do number 5. Number 5 says y equals 2x to the 7th minus x squared times x minus 1 over x plus 1. And the directions say find dy dx such that x equals 1. So this means we're going to find the derivative, and after we find the derivative, we're going to substitute 1s in for the x and actually get a numerical answer. Now, look at this function. Are we going to use the product rule, or are we going to use the quotient rule for this problem? What do you think? There's kind of both a product and a quotient in this problem, but the overall problem is like this is in parentheses times this is in parentheses. So this is a u times v situation. So I'm going to call this u and this v, and I'm going to apply the product rule. dy dx is equal to. So I'm going to copy my first function, 2x to the 7th minus x squared, and I'm going to multiply it by the derivative of my second function. But guess what? When I take the derivative of the second function, I have to use the quotient rule. So it's like an embedded quotient rule problem within a product rule problem. Isn't that exciting? Okay, so we're going to start with the denominator. Multiply it by the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator squared. So all this right here in my parentheses is the derivative of v. This is my v prime, u v prime, plus v, so copy down the second function, times the derivative of u. This is u. We're gonna find the derivative of this function u to get u prime. So that's gonna be 14x to the 6th minus 2x. Okay, we do not have to simplify this, thank goodness, because this is a plug-in and x equals 1 kind of problem. So we've done the derivative at this point. There's no need to simplify it. It wouldn't be wrong to simplify it. I just think it would make this problem more lengthy than it needs to be. And we have a nice easy number like 1 to sub in for the x's. So that's not going to be too challenging to work with. So I'm just going to go through and write the exact same thing that I have, except for everywhere I find an x, I'm going to replace it with a 1. And now I'm going to do some arithmetic very carefully so we don't make a mistake. So this is 2 times 1 minus 1. So 2 minus 1 gives me 1. Here I have 1 plus 1, which is 2, times 1, still 2. Minus 1 minus 1 is 0, times 1 is still 0. So this was 2 subtract 0 in the numerator. So I have the numerator, is that right? No, 2 subtract 0 is 2. My numerator is 2. I better write this down. And then on the denominator, I have 1 plus 1, which is 2, squared is 4. Plus, here I have 0 over 2, and here I have 14 minus 2. So dy dx is equal to 1 times, this simplifies to 1/2, plus 0 times 12. So this is 1/2 plus 0, which is 1/2. Oh wait. Such that x equals 1 is 1/2. So I forgot the such that x equals 1. As soon as I plugged in the 1, I should have put that on my symbol here. Okay, nice number, 1/2. Let's move on to the next problem, number 6. We have y equals 2x to the 5th minus 3x to the 4th plus 5x cubed plus x squared minus 7x plus 187. Wow, that's fancy. And the directions say find this y with a little 6 in parentheses. So the little 6 in parentheses means like the 6th derivative, because we don't write 6 slashes. Usually the most slashes they'll write is like 3 or 4, and then they start putting some number in parentheses up there, which means the same thing, except we just don't have all those slashes. So all those primes. So we're finding the sixth derivative, so we better get busy. Y prime is, power rule, 10x to the fourth minus 12x cubed plus 15x squared plus 2x to the first minus 7. Now y double prime, 40x to the third minus 36x squared plus 30x plus 2. Okay, y triple prime, see, 120x squared minus 72x plus 30. Okay, I'm gonna quit with the slashes here and put the little 4 in parentheses. The fourth derivative is 240x to the first minus 72. And the fifth derivative is 240. And the sixth derivative is 0. So the answer is 0. What if I'd asked for the seventh derivative? What's the derivative of 0? Still 0. Every derivative after that would be 0. Does the derivative always go to 0? What do you think? What if I had started with y equals 1 over x squared? That's the same thing as x to the negative 2, right? Y prime would be negative 2 x to the negative 3, which is the same thing as negative 2 over x cubed. Y double prime would be 6x to the negative 4, which is 6 over x to the fourth. Y triple prime would be negative 24 x to the negative fifth, which is negative 24 over x to the fifth. Are these going to 0? No. The negative powers just grow to be larger powers of x in the denominator of the fraction. They won't go to a constant of 0 like the regular polynomial functions will. Okay, number 7. F of x is equal to the cosecant of x times the cotangent of x. So this is a product rule problem. We're going to call the first function u and the second function v. F prime of x is equal to, we're going to copy the first function, cosecant x, multiply by the derivative of the second function. The derivative of the cotangent function is negative cosecant squared of x plus the second function copied down, cotangent of x, times the derivative of the first function, negative cosecant x cotangent x. So you should have all 6 trig function derivatives in your note card stack at this point, and make sure you are studying those because you will need to know the sine and the cosine that we learned first, and also we are adding to that the secant, the cosecant, the tangent, and the cotangent. So make sure you've got all of those in your note card stack and be studying those. So I'm just going to simplify this a little tiny bit because we have a cosecant x times a negative cosecant squared of x, which is negative times positive makes negative. Both of these are cosecants. And this is to the first, that's squared, so you multiply that and you get cubed. And then this next one, we have 2 cotangent x multiplied by each other, so we can make that cotangent squared. So minus cosecant x cotangent squared of x. And that is the final answer for this problem. Number 8. I have f of x is equal to the secant squared of x minus the tangent squared of x. So, on this problem, we have a couple of different options. I want to recommend that you push pause and try this problem on your own and then come back to it and see if you got it right. And I'm going to assume that you have done so. And so what did you get? If you were here, I'd be dying to know, but unfortunately I can't hear you tell me your answer. So the answer is 0. And there's a couple of different ways to get it. So I'll start with the one involving the product rule, because that's what we just learned. Secant x times secant x minus tangent x times tangent x. So we have to do the product rule twice here, actually, to make this work. So f prime of x is copy the first function, multiply by the derivative of the second. The derivative of the secant x is secant x tangent x, plus second function copied down times the derivative of the first, secant x tangent x, minus, I'm going to put a big bracket here because the whole thing's being subtracted, so the sign will distribute. So I'm going to take my tangent x and multiply it by the derivative of the second function. The derivative of the tangent of x is secant squared of x, plus copy that second function, tangent of x, and multiply it by the derivative of the first, secant squared of x. Okay. So now f prime of x is equal to secant x, tangent x, plus secant x, tangent x. Notice these are the same thing, so I'm going to put 2 secant squared x, tangent x, minus, here I have tangent secant squared x plus tangent secant squared x. Those are also the same, and they're also the same as this, so 2 secant squared x tangent x. And this minus this is equal to 0. All that work for a 0. Okay, now some of you are probably dying right now to be like, why did you do it that way, Mrs. Heiss? I know a faster way. And I'm so happy that you thought of that, because some of you may have remembered from pre-cal that you learned 1 plus the tangent squared of x is equal to the secant squared of x. That's a Pythagorean identity from pre-cal, a Pythagorean trig identity. So it just so happens that this is a lot like this if you were to subtract the tangent squared of x on both sides. So 1 equals the secant squared of x minus the tangent squared of x. So I could have, in the very beginning at this problem, taken f of x and replaced secant squared of x minus the tangent squared of x with a 1. And if I said f of x is equal to 1, then the derivative of 1, the derivative of any constant, is 0. And gotten that answer with a little bit less work. So what's the moral of the story, boys and girls? The moral of the story is sometimes we can use those trig identities that we learned in pre-cal to make a longer problem into an easier problem, which is wonderful. So keep that in mind. However, there is often, almost always, usually a way to do the problem without using that trig identity. It's just going to take a little longer, a little bit more work to be done. All right, we shall move on now to problem number 9. And for problem number 9, we're going to use what I call the triple product rule. So if I want to do the derivative, of u, v, w, so I have a product of 3 functions. it's going to be very similar to the original product rule, but it's like each term will have all three UVW, 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 and in each term a different one will take turns being the one that you put a prime on. So like copy the first, copy the second, take the derivative of the last. Copy the first, take the derivative of the middle, copy the last. Take the derivative of the first, copy the second, copy the last. This rule can also be expanded to products with even more factors than just 3, in the same way where you just write all the factors down and one factor in each term will have the prime on it, and that will switch from factor to factor. And because they're separated by sums, it doesn't really matter which one you start with the derivative on, because they could be added in any order. So this is like kind of a sub note card of your product rule. It's an extension of it. I don't see this come up very much on the AP exam, but I don't leave anything out when I teach you AP Calculus. I want you to have all the tools that you need regardless of where you're headed next. So we cover it all. All right. Now, my function that I'm going to take the derivative of here, and we'll do an easy one, is x minus 2 times x plus 1 times 2x squared plus 4. So we're going to find the derivative f prime of x. So the way we do that is we are going to copy the first, copy the second, take the derivative of the last, plus copy the first, derivative of the middle, copy the last, and then derivative of the first, copy the middle, and copy the last. So each function gets a turn having its derivative taken. This is u, v, w. This is u, v, w prime, plus u, v prime, w, plus u prime, v, w. So that's how I did that. So then the next step is to simplify it, which is, the algebra is way more work than the calculus. The calculus is done. So here you have to FOIL x squared plus x minus 2x minus 2, and then that gets multiplied by 4x. Here we have to FOIL, so 2x to the third plus 4x minus 4x squared minus 8, plus here we also FOIL 2x cubed plus 4x plus 2x squared plus 4. And then we simplify for the rest of our lives. Distribute the 4x squared plus 4x minus 8x minus 8. And I'm just gonna copy the rest. So now I've got all my terms listed, and now I'm gonna go through, find my like terms to combine. So let's see, cubic terms. I have a 2 and a 2. Is that it? I feel like there's another one. Nope, that's it. So 4x cubed, and then I need quadratic terms. So 4x squared minus 4x squared, so that makes 0, plus 2x squared. And then we need a linear term, see 4 minus 8. Oh, I already did double underlines, so let's do zigzags. 4x minus 8x is negative 4x plus 4x makes 0, plus 4x makes another 4x, and then minus 8, I already did a circle, let's do a triangle. Minus 8, that's negative 16, plus 4 is negative 12. Okay, now, I could have made an arithmetic error in here. It is possible that I may have done so. So if I did, I apologize. But I want to tell you on this problem in particular that if it's a free response question, this includes on the AP exam and on my classroom tests. If you are told to find the derivative and it's not a multiple choice question where you have to make your answer look the same as theirs, then on this step right here, you stop and you don't do anything else because you have taken the derivative at that point, and there's no rule on free response questions that says you have to simplify your answer unless it explicitly says simplify your answer in the directions, which it would not be likely to do to say that on a problem like this. So just wanting to alert you that we don't want to miss points on a problem because we had the right work and then we went and messed up the answer by simplifying incorrectly, because your final answer will be graded as your answer, and you won't get a point for your answer if your answer is wrong. You can still get a work point for applying the proper formula and showing that, but you won't get the full credit if you go and destroy it by messing it up and writing something that is not equivalent to the correct answer. All right, we have one problem left. And on this problem, it is also going to be at one where I'm going to tell you, do not simplify your answer. Please do not. Just take the derivative and stop, okay? So g of x is equal to x squared times the quantity 2 over x minus 1 over x plus 1. There is more than one correct way to solve this problem, so you do it however you want. Pause the video, work it out, but do not get a final answer like simplified. Just do the derivative and then stop. Okay, I'm going to assume that you paused your video and that you're ready to check and see if you did it right. So, on this particular problem, I would be likely to go ahead and distribute this before I started taking the derivative. So I'm just rewriting the function. 2x squared over x minus x squared over x plus 1, because this x squared is like it's over 1 and it would distribute. Then I would simplify. X squared divided by x is x, so 2x here, and then I still have this rational function that cannot be simplified any further. So I'm going to find the derivative, g prime of x, by taking the derivative of the first term. The derivative of 2x is 2, minus, and then I'm going to put a bracket. Now I'm going to take the derivative of this next term. I have to use the quotient rule, so you start with low, the bottom, the denominator, always. X plus 1 multiplied by the derivative of the top, 2x, minus the top, x squared, times the derivative of the bottom, 1, all divided by the denominator squared. Now, that's my answer. I have finished taking the derivative. Okay, it's not simplified, but I told you don't simplify on this problem. So that's how I would have done this problem. If you did it another way, that's fine, that's good. I like lots of ways of thinking about problems, and I like to explore them, and if we were together in class, we would share out the different ways that we looked at this problem to work it out. I imagine I would hear somebody say that they took this first function to be u and this second function to be v, and used the product rule to do this. So first function times the derivative of the second function plus second function times the derivative of the first function. That is a valid way to work this problem, and that will get you the same answer once it's fully simplified. If you want to check to make sure you executed that correctly, you can always go into y equals in your calculator, put my answer in y1, put your answer in y2, and then compare the tables to see if the values are looking the same. If they are, then you have something equivalent, okay? So that's a good way to check. But at any rate, that is our lesson today, a little bit more brief than many days. Be sure that you study that product rule, that quotient rule, and all those trig derivative rules very thoroughly so that you have those in your brain as we move forward throughout the course, because those should be like your multiplication facts. What is 3 times 4? You can tell me that very quickly. I need you to be able to tell me what is the derivative of the tangent of x? Secant squared of x. Give it to me quick. I want to know it, okay? What is the derivative of the cotangent of x? Negative cosecant squared of x, okay? So be sure to study those and know them, commit them to your memory. And I wanted to point out also the derivative of all the functions that have a c in front of them, like cosecant, cotangent, cosine. Those are negatives. And the ones that don't have a c in front of it, the sine, the secant, and the tangent, those are positive derivatives. So that might help you with remembering which ones are positive and which ones are negative. So study your note cards in addition to doing your assignment, and I look forward to our next lesson. Have a wonderful day. Bye.